Hi guys, today's video is about Venn diagrams and two-way tables. So let's just go ahead and get started to keep this video short. So today we're going to be talking about two-way tables and Venn diagrams. We are still in our probability unit, and what we are talking about essentially today is two ways that we can display events that involve probability. Okay, one is using two-way tables, which describes like different events in table form, as well as Venn diagrams, and then we can use these to determine probabilities of different situations. Okay, so these are visuals for probability situations. So before we talk about that, we need to talk about a couple of definitions: union and intersection. Okay, so the union is when one event or another event occurs. Okay, when one event or another event occurs. We'll give an example of that in a moment. Intersection is when one event and another event occurs. Might be like, Mr. Shu, what does that mean? What do you mean by that? Okay, what's the difference? Well, I'll give you an example. The card picked out of a deck of cards is a heart or a face card. That is an example of union. Okay, so if I'm picking a card out of a deck, it could be a heart or a face. The card picked out of a deck of cards is a heart and a face card. So it must be a heart and a face card. Okay? So, hopefully you'll realize with these three cards that the Jack of Spades, okay, fits this description, but does not fit this one because it is not a heart. The Seven of Hearts fits this description, but doesn't fit this one because it is not a face card. And this one fits this description, and it fits this because it is both a heart and a face. And I should have put one more card on there, which is like a Five of Clubs, which would fit neither. Okay, I should have put it up there, but I didn't. I apologize for that. So union is generally broader, okay? It is more inclusive. It includes more possibilities. And intersection is more exclusive, as in both must be true. That is intersection, okay? Union is either or can be true of the events, and intersection is both have to be true, okay, in order for it to be a part of the intersection. So let's take a look at all of the events within that scenario. So if I have the event of selecting a face card and the event of not a face card, if I look at like the whole scenario, okay, or sorry, the event face card and the event heart, not face card, not face card, face card and heart, okay? So it could be what? Heart or not heart, or face card or not face card. And these are all the possibilities. Now, where did all of these numbers come from? Face card and it's a heart. That's these three cards right here. Okay? Face card that is not a heart. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not a face card, but is a heart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And then the rest of the cards that are not hearts and not face cards. 1, 2, 3, 4, 5, 6, 7. Right? So on and so forth. There are 30 of them. Okay? Okay. And then when I add them all up, right, the total number of face cards is 12. Right here. Okay, total number of not face cards is 40, 1 through 10 of every suit, right? Okay, total number of hearts is 13, and total number of non-hearts is 39. Okay, all right, so if I look at the situation, the event, picking a heart, let's define that as H, and F as picking a face card. Okay. Union is defined with a U. Okay. So the probability of heart or face, that's what? 22. Now, where did I get that number? Heart or face. Well, that's what? This 3 plus this 10 plus this 9, which is what? 22 over 52. Done. Which is 11 over 16. Right? Okay, where do those come from? 1, 2, 3, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There are 22 heart or face cards out of 52. And if you simplify it, that's 11 out of 26. Okay, if you have the probability of heart and face, that means both have to be true. That's just what? These 3 out of 52. These 3 hearts out of 52. That's the probability. Okay? Now, here's the general probability rule for addition. Okay? This is the relationship between intersection and union. Okay? The A or B is what? Union. And the A and B is the intersection. Okay? So A and B can be any events. Okay? I just want to be clear on that. The reason why I didn't write it as H and F is this is the general probability formula. Okay? So I just want to show you that this actually works. Okay, so what if this was H? The probability of getting a heart is what? 13 out of 52. The probability of getting a face is what? 12 out of 52. If you add those two together, you get 25 over 52. If you subtract the intersection of heart and face, that's what? This value right here, 3 out of 52. You get 22 out of 52, which is the union of probability A or B. Whoa! That's pretty cool, isn't it? That's how they're related. Okay, all right, cool. So, yeah, we need to move on probably. Okay, another way of displaying this is Venn diagrams. Okay, so the number of hearts here is 13. So there's 10 hearts that are not face, 3 hearts that are face cards, and then there are 9 face cards that are not hearts, and then there are 30 cards that are neither heart nor face. Venn diagram is just another way of displaying the data, okay, of union and intersection. Generally, the events are displayed in circles, okay, and wherever their intersection is where the circles overlap, and outside of the 2 circles is not those 2 events or the complement of those 2 events. Okay? Okay, cool. So your homework is there. You should have everything that you need to be able to complete it. Hopefully this video wasn't too long if you didn't attend the live session. If you have any questions, email me. Bye now.